Okay, good evening, Prof. Kairu. And this is a video presentation for EMM 3526. And today we have our title, which is VVlog, and we are for group 10. So there are a few members of our group, so which we will introduce ourselves. And my name is Andy Wakil with metric number of 19584.
And my name is Chu Yong Ken with the metric number 195917. Okay.
My name is Ong Jun Lin with the matrix number 199120.
All right, so now let's move on to the introduction. So right here, introduction, at the first point, we'll have CATIA is a multi-platform software. So by the way, I will be explaining about CATIA. It is a multi-platform, as I mentioned just now, which is suitable for computer-aided design, computer-aided manufacturing, and also engineering. Which another, for addition, we also have PLM and 3D, which is developed by the French company. All right, so the main focus of this report is the prismatic machining feature in CATIA, where it helps to define and manage the NC program dedicated in 3D wireframe or solid geometry using 2.5 axis machining techniques. So in this prismatic machining, a CATIA drawn VVlog by us will undergo the process of prismatic machining. So which in general, the VVlog is one that we use to hold round metal rods or pipes or to perform the milling operation. They consist of a rectangular steel or cast iron block with a 120-degree channel rotate 45 degrees for the sides, forming a V-shaped channel in the top. So a small groove is cut in the bottom of the V. So they often come with the screw clamps or which is to hold the work. Actually, in real life, the VVlog is being manufactured by using milling operation, which the 2B has to be specialized by having sufficient hardness in order to have the milling process on the VVlog. Therefore, a virtual machining will be done on this VVlog by using the prismatic machining feature in CATIA. All right, so now move on to the objective of our project. The first one is to successfully utilize the prismatic machining feature on VVlog. And the second one is to generate the NC code for the machining operations. And the third one is to draw the appropriate part using the CAD software using the 3D modeling technique. Now for the design wise, I will be passing on to the person in charge.
Okay, so thank you, Andy. So for the design, so basically, based on the guideline, we were required to choose at least one element from the entire assembly. So for VBlock, as per mentioned by Andy in introduction, VBlock is basically the clamp that holds a circular tube and can be differentiated into two parts. One is the clamp itself, another is the VBlock itself. So we have a several discussion and we evaluate that the VBlock is actually the more complicated or more important part in the entire assembly. So we choose VBlock as our design. And since VBlock has a much easier design compared to the other, so we actually choose this for our design since it will be better for us to show this design instead of the others because it's simpler, and when we carry out machining, it will be more easy for us to carry out the simulation. So for the design wise, there will be two steps. The first step is actually pretty simple and based on the drawing given as shown on the slide. So this drawing is actually obtained from a website that we research on, and the drawing gives quite a numbers of parameters as well as the nominal dimensions and the tolerance. But in our case, we'll be taking on the nominal dimension only. So the tolerance will not be in our consideration for this part for design. So first, we section the design before into two parts so that we can carry out a function known as mirror in our 2D sketch. So first, from the A3 drawing, we can see a few dimensions. The first dimension will be the whole square where it indicate the pad on the right side. It's basically the side view of the geometry, and the left side it will be the front view of the geometry. So here basically it's a square, and so the side and the top and the side length will be equal. And since I've mentioned just now that the nominal dimension will be our only priority for geometry design, so for the length we'll be taking 1.9375, and that will be our first step in geometry generation. So a square will be drawn where it will be sectioned into half, so we can carry out mirror function. And at this case, the 1.9375 will be divided by 2. And after that, we'll start on doing the curve and the hole on each side. So for the curve, we'll be doing, for the side, the upper part of the side extension, it will be 0.234. And the curve, the length height will be 45 degree. At here, it will be 90 degrees since we'll be taking half, as I've been mentioned. So it will be 45 degree. And by taking 45 degree, we'll get the slang length. And then we take the hole. we start to generate the hole where the length will be 0.77 from the top plane. And next we'll do the same for the bottom part, but with different dimension, which is 0.484 for the side extension, but the angle will be equal as the top plane, which is 45 degree, and the length or the distance from the bottom plane to the middle hole will be 0.52. And next we'll do the side hole, which is 0.375, as we can obtain from the right view, or right hand. On our right hand side there will be a side view, and the middle hole will be 0.375. Next we'll do mirror on Y plane, and we'll get the entire geometry, which is the front view as shown on the left hand side. And then we'll pad for 1.9375 as well, since the entire geometry will be in a cubic geometry, so it will be equal in length for the entire side, which is 1.9375, and that we will obtain the geometry as shown in our next slide. So next slide. So as you can see, the slide on our slide, there will be a geometry within a square body, where the square body is basically the second body or the outer body that will be needed for machining purpose. And after we obtain the geometry in the entire cubic or the second body, which is shown in the slide, we'll start on progressing on generating the second body, which is basically just a cube, and the dimensions are projected using function of project 3D element by inserting a new body and sketching on the new body plane, and generate a 3D element on each side and pad for an equal length as the entire geometry, which is 1.9375. We'll be obtaining the second body. And after we obtain the second body, we'll move on to machining, which will be explained by Ju.
Okay, thank you, Jun. And now is the machining part. Okay, first we have two machining involved in this process. Okay, first is the prismatic machine. In prismatic machining, we have used the phasing machining and the pocket machining to do the top and the side view of the V box. And then we will switch to the surface machining for the roughing and shaping. Andy, sorry. Your slide. Okay. We will switch to the surface machining for doing the roughing and shaping process. Okay. Now, I would like to sharing my CATIA screen to more detail to explain the about the machining part. Okay. Andy, please stop sharing. Okay, thank you. Okay. Okay. Can you guys see this? Okay. Yeah. Okay. Now I would like to start the machining part. Okay. First we have to click the start and machining in prismatic machine after doing finish the part design. Okay. First we will see this is still not hiding. Okay, like this. Okay. Then we have to hide the second body. Then we have to click on the part operation one to select the design and the slot. Okay, first the design part. After we click that, then we select the whole body. Okay, it's the design body, and the stock we will select the hidden body. Okay, then okay we move on that. So after that we need to start our machining. Okay, first we have to do it from the top to until the bottom. Okay, first we'll start to using the face machining. Okay, just a minute to find the icon. Okay, yeah, I need to use this icon face machining. Then after clicking, we have will be appearance this yeah, this. So we have to select the control for each part. Okay, first the drive we will select in the bottom is the top right here. Okay, then the side quarter we will select the whole side, okay, of this body. After that we have to choosing our tube pass type. Okay, we for this part we have used the invert halide, and the other setting is still remain the default. Okay, after that we have to proceed with the proceed with it. Okay, then so we can check it on the replay. Yeah. Okay, this is the first step of the block. Okay, the facing is done. Okay, next we are continue with the pocket. Okay, after finish that, this click OK, then cancel. Next is the pocket. Okay, yeah. Just a minute. Yeah, pocketing for the side. Okay, so we still the same. Select the pocket icon, pocketing icon, then we click on this after defacing, then we show is after that. Yeah, so it's the same, so we have to yeah, okay, we have to select the control for each side. Okay, first we have to select the yeah, the bottom of the of the surface. Yeah, so we have select first, we have select the bottom, then we have to select the top. Okay, as the part, and then we have to yeah, you can proceed with it with the select the truth bar side. Okay, it's still the same. Then this time we have select the outward highlights, and the other setting is still remain the same. And okay, for the two part we have select it and try to change the dimension into 0.2 inches. Okay. Okay, then we have to proceed with it with the two bar replay. Yeah. So we can check it. It's still the same. Okay. After we have doing the surface and the pocketing. Okay. So the the pocketing is appearance after review that. Okay. So we still on the correct correct procedure. Okay. So for the right side part is still the same as we do as the previous pocketing. Okay, select the pocketing icon, then click on the first pocketing, then still the same. Okay, the setting and the dimension of the two part is still with before that same as the before. Yeah, then okay, we can review after finish the selection of the control and the dimension of two part. Okay. 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 So Yeah. So okay, so now the prismatic machining part is done. Then we have to move on to the surface machining. Okay. So same as before, we have click start and machining. Then we select the surface machining. Yeah. Okay. So after that, we have to we have to select the part operation again. Okay. First, we have to select one more machine safety plate. Okay. For the safety plate, we have to select on the top. Yeah. As the surface. Okay. Then we carry on. Okay. After that, we have to. Yeah. Sorry. Once again, I'm missing something else. Okay. The machining also is the same. We have to select 3-axis machining. Make sure this is 3-axis machining. Okay. Yeah. And the reference, yeah, the for reference machining is select on this point. Yeah. On the model. After that, we have to carry on with the roughing. Yeah, roughing process. Okay. Okay. Yeah. For the roughing process, we can click on the roughing icon. Yeah. Sorry. After clicking the roughing icon, you can show it there. Okay. Yeah. Okay, roughing. Then we select all the detail part. Okay, for the bottom, we select first we select the part. Okay, part is mean the whole body. Yeah, after clicking this, you select the whole part. And then the safety belt is select on this side, and the bottom is over here. Okay. Then we have to proceed with the machining. Okay. First, we have to select the two path. Okay. For this, we have selected helical machining, and the reticle we select the step over ratio, and acid. Yeah, tip cut for the acid we select 0.52 in this. Yeah, for the tip of the cutting. And yeah, then we proceed with it. Yeah. Okay, so the dimension is still need to change with the 0.2 inch. Okay. Yeah. Okay. After done, we need to review the two-part repair as well. Okay. After that, we have to continue with the shipping process. Yeah. Okay, we have to okay, before that we review the roughing process first. Okay. Yeah, okay. This the roughing process showing that. Yeah. Okay, then we proceed with the shipping process. Next is the shipping process. In the icon, this the shipping icon. Then click on it. Then we will need to select after the roughing. Yeah. So it's still the same. So first we have to select the control first. Same as before. The control select the part on whole body. The safety plate on this surface, and bottom is still at the bottom side. Okay. So after that, we have to trying to setting of this. Yeah, we have to click on this icon and select the coordinate. Okay. Then after that, we have to choose the machining. For this, we have used the zigzag machining, and yeah, the other setting is still remain the same. After that, still remain the same. After we have changed the acid, okay, all is still remain the same. Yeah. Then we proceed with it. We replay. Yeah. Okay, so the surface on top is appearance after we replay it, so it's still on the right way to continue our machining. Okay, so same is still the same step for the bottom side. Okay, first we choose the roughing again. Okay, roughing again, but this time we have to change a little bit different. Okay, okay, same as the previous. The part we choose the whole body. The rough stuff is on here, and the safety black we still select on the bottom. Okay, we have to like the in class. Okay, for the bottom we select the top part of the body. Okay, so the other is still the same. Okay, for this type the machining two part style we have used spirit, and yeah, two is changing to spirit, and the radius is still the same, and the setting step over we have to change to step over ratio, and the SER is it's the same with the 5 point. Oh, sorry, I think I select wrongly. Okay, 0.52 inch for the tip of the cut. Okay, then the other is still the same, so we review it. Okay, okay, it show a cut in the middle. Okay, then the last process is the shipping. Yeah, shipping process again. Okay, so we click the shipping icon, then we show the sorry. Okay, same as previous. Then we have choose the control first. Yeah, the part is the body. The safety black is on the bottom. Okay, left bottom, and yeah, and the bottom is choose the top black. Okay. So oh yeah, same as the previous shipping. Then we have the machining tooth part style is still the zigzag, and yeah, the other is still remain the same. Yeah, remain the same. So then we proceed with the replay. Yeah. Okay, this the replay. So I think this a little bit quite faster. So I try to replay it again. Yeah. First is the top shipping. Okay, then move to the bottom side. Yeah. Okay, so this the machining process. After that, we can save the file. Yeah, then we have to move on to the NC code part. Okay, so I pass it to NT. Yeah.
All right. So I can share my own screen. Okay. Okay, so thank you, Shu, for presenting about the steps of machining. And right now, can you guys hear me? Hello?
Yes, yes.
Okay. So right now I will be presenting about the steps to generate NC code. So there are a few steps which they are very easy. So first is to about the option, and then you click on the machining and select the IFS as the post processor. So after that, go back to your go back to the tree branch, and then right click on the part operation and select. After that, a table will come up, which you can select the machining editor to change the following parameter, where there are the post processor and also the post processor words table. So after you have changed the parameter, you will go to on the same table, you go to the generate MC, go to the icon and you search for the go generate NC output interactively. And then you change its parameter, which there are two you need to change, where there are the NC data type and also the NC code. So for the NC code, we need to take note that we need to choose Okuma, which is for our syllabus. And then lastly, you can click execute and the file is generated. So these are the steps which are easy to generate the NC code. So lastly, I will conclude the overall the report of our presentation. Actually, for the first one, the objectives are well achieved, but to be honest, the outcome is not as expected due to the following reasons, which we have tried to figure out the problems of why we encountered those failures, as just now it can be seen in the presentation of Chiu. Actually, for the surface machining, it doesn't seem to be very smooth, as you can see some rough surface on it. That's why there are 3 points where there are. The first one is the inappropriate function is chosen. So for the second one, we might miss out some important steps that will affect the outcome. For the last one, which it might be the incorrect surface is chosen while doing the simulation setting. So this may be due to the insufficient exposure to the CATIA surface machining interface, because for our syllabus, we only learn about the prismatic machining. So actually, to sum up everything, the case study is indeed useful as a stepping stone for us, since we can we are to be exposed to a greater to related industry, especially for the CNC coding, so which in our computer aided manufacturing. So okay, so that's all for our presentation. So anything to add on, Chiu and June?
No, I think.
I think that's all.
All right. Okay. So thank you.
Thank you.